Imagine you are standing on the deck of a Viking longship. The wind is violent. The sky is thick with gray clouds. The North Atlantic stretches endlessly in every direction. There is no GPS, no compass, no visible sun. And yet, somehow, you must know exactly where you are. One wrong direction means starvation, one miscalculation means vanishing into history. Now here is the question that has puzzled historians for centuries. How did the Vikings do it? How did Norse sailors leave Scandinavia, reach Iceland, settle Greenland, and arrive in North America nearly 500 years before Columbus without modern navigation tools? The answer might lie in something small, transparent, and almost magical.
Every piece of technology hides a story of vision, rivalry, and forgotten battlefields. From ancient machines to world-changing inventions, every breakthrough has a past worth remembering. This is the technological past, where history and innovation collide, and the stories of yesterday shape the tech of tomorrow. Subscribe to the Technological Past, because here you'll uncover the hidden stories behind technology, history and innovation that shaped our world, and get a glimpse of the upcoming tech gadgets transforming the future.
A crystal known today as the Viking sunstone. The idea first appears in medieval Icelandic texts. In one saga, a king holds a sunstone up to the sky to locate the sun's position on a cloudy day. For centuries, scholars dismissed this as poetic exaggeration, mythology, not science, but what if it wasn't? What if the Vikings possessed a navigation tool so advanced that it disappeared from history? To understand this mystery, we need to step into the Viking world, a culture of shipbuilders, traders, explorers, and warriors who mastered the sea between the 8th and 11th centuries. Their longships were engineering masterpieces, flexible hulls, shallow drafts, symmetrical designs allowing quick reversals. These vessels weren't just built for coastal raids, they were capable of open ocean voyages. But ships alone don't conquer oceans, navigation does. Before the widespread use of the magnetic compass in Europe, sailors relied on landmarks, stars, wind patterns, bird movements, and experience. But the North Atlantic is unforgiving. Fog rolls in without warning, storms swallow the horizon. For days, sometimes weeks, the sky can remain overcast. Without the sun or stars, direction becomes guesswork, unless you have something else. In the 20th century, scientists began exploring whether certain crystals could help locate the sun even when it is hidden behind clouds. One mineral stood out, Iceland spar, a transparent form of calcite found in large deposits in Iceland. Iceland spar has a remarkable optical property called birefringence. When light passes through it, the crystal splits it into two rays. More importantly, it interacts with polarized light. Here's where it gets fascinating. Even when the sun is obscured by clouds, sunlight still scatters through the atmosphere in predictable polarization patterns. Human eyes cannot detect this polarization directly, but certain crystals can. When you rotate a piece of Iceland spar under a cloudy sky, the brightness of the double image changes. By carefully adjusting the crystal, you can determine the direction of the sun's hidden position with surprising accuracy. In controlled experiments, researchers have shown that such crystals can locate the sun within a few degrees, accurate enough for navigation at sea. Now consider this: Iceland spar was abundant in Viking territories. The sagas mention a sunstone. The Vikings were among the greatest navigators of the early medieval world. And in 1971, something extraordinary happened. A navigational instrument recovered from a 16th century shipwreck near the Channel Islands contained a piece of calcite crystal, possibly used as a backup navigation tool when magnetic compasses malfunctioned near iron cannons. This discovery suggested that crystal-based solar navigation was not only possible, it may have been used far longer than previously believed. If 16th century sailors used it, why not the Vikings centuries earlier? Imagine the scene again. A Norse navigator stands at the bow of a longship. The sea churns violently. He He lifts a small crystal toward the gray sky, rotates it slowly, watching the light shift inside. He marks the sun's hidden position. He adjusts the ship's heading. And just like that, the ocean becomes readable. This wasn't magic, it was physics. But to a world without formal optical science, it would have seemed mystical. The Vikings may not have understood polarization in modern terms, but they understood patterns. They understood nature. They were masters of observation. And here's what makes this even more impressive. They navigated across thousands of kilometers of open ocean to reach Greenland, one of the harshest environments on Earth, and established settlements that lasted centuries. Around the year 1000, Norse explorers led by figures like Leif Erikson reached North America, landing at what we now call Lands o' Meadows, nearly 5 centuries before Columbus. This was not accidental drift. This required repeatable navigation, precision, confidence, a method. And the sunstone may have been part of that method. Critics argue that no direct Viking sunstone has been conclusively found in a clearly Viking archaeological context. That's true. But absence of evidence is not evidence of absence, especially when dealing with small, fragile objects that could easily be lost, broken, or repurposed. The combination of saga references, optical science, geographic access to Iceland's spar, and experimental validation makes the sunstone theory one of the most compelling explanations for Viking open ocean success. What makes this story powerful isn't just the crystal itself, it's what it represents. The Vikings were not merely raiders in horned helmets. That image is largely fictional anyway. They were innovators, engineers, observers of the natural world. They built ships that flexed with waves instead of fighting them. They read currents like roads. They may have used the sky itself as a compass. And in doing so, they expanded the known world. Think about that. Centuries before the age of exploration, before global empires, before modern instruments, a sailor holding a small crystal may have been decoding the atmosphere itself, using the invisible properties of light to conquer the ocean. That is not primitive, that is sophisticated environmental engineering. The Viking sunstone challenges the idea that ancient navigation was crude or accidental. It suggests a lost layer of knowledge, subtle, observational, precise. Today, when we rely on satellites orbiting Earth to tell us where we are, it's easy to forget that direction once depended on human perception and intimate knowledge of nature. The sunstone is a reminder that technology doesn't always look like machinery. Sometimes it looks like a simple crystal, sometimes innovation is invisible. And sometimes the key to crossing the most dangerous ocean in the world fits in the palm of your hand. If this story changed the way you see the Vikings, hit the like button. It helps more people discover the hidden genius of the ancient world. Subscribe and turn on notifications for more lost technologies, ancient engineering secrets, and forgotten innovations that shaped history. And tell me in the comments, do you think the sunstone was real Viking technology or a brilliant legend rooted in science? Because if a crystal helped Vikings navigate the Atlantic, what other ancient tools are we still underestimating? History isn't primitive, it's powerful. And we're only just beginning to rediscover it.